So what questions do we have out of 5, 1? I know
1 and 15.
Okay, 1 and 15.
14.
And 14 as well. These are out of 5, 1.
9.
Okay, question 9. And we have plenty of time. What you really need to know how to do for college algebra is how to factor those trinomials and how to factor out the greatest common factor. So we've got to make sure we're really good at 5-1 and 5-2. Those are very, very important skills for college algebra. The other parts are not as important, so I was able to cut those out. Again, that's just because we missed a lot of class periods for weather and things that were out of our control.
4 and 8.
Okay, and that's out of 5-1. Okay, 4 and 8. Other questions out of 5-1? Okay, what about 5-2? Sure, we've got some questions out of 5-2 to look at. Which 4? Okay.
14.
14, sure.
How many pages can we have on the final?
Okay, what you can have on your final is you can have 1 page of notes, front and back, or note cards, just like any other exam. And you can make, if you want to make 15 note cards to get you ready for the final, you can do that. So any other questions out of 5-2? Which one? 20, sure. And we'll come back and we'll do 10 here later on, because we haven't covered 10 yet. So we'll cover 10 as soon as we finish up. Yep, sure. So as soon as we finish up the questions out of 5-2, then we'll look at question 10.
24.
Okay, which one? 24?
Yep.
Okay. Are there any others to look at? Anything else? Let me turn that light off so it's a little bit easier to see the screen here.
And 25, please.
25? Sure. Okay. And if it takes us a good hour and a half to go through all these, that's fine. Because all we're going to do for the rest of the class is work on questions from that practice file that I'll give you here in a moment. I've got it all printed off up here. Okay. We'll go ahead and start with 5.1 then. And we're going to begin with question 1. And these are factored by grouping or factoring out the greatest common factor. Okay, so question 1, we've got 3 minus 3s plus s squared minus s cubed. Where do we begin? Well, what we want to do is we want to count the number of terms that we have. And again, terms are separated by addition or subtraction. So we've got 4 terms. When you have 4 terms, you want to factor by grouping. So you group the first 2 together, and you group the last 2 together. And so let's see what we can do here. If we need to rearrange the terms, we can, but I don't think that we'll need to. So when we look at the first 2 pieces, what can we factor out? The first 2 pieces, they have the number 3 in common, don't they? So we're going to factor out a 3. And that leaves us with, when we factor that 3 out, 3 divided by 3 is a 1, so that leaves you with a 1. The 3 comes out, and that leaves you with minus s. So that's the first 2 pieces. The second 2 pieces, what can we factor out of it? Well, they both have not just an s, they have an s squared in common. So we're going to factor out and s squared. When we factor that s squared out, it cancels, but we leave that 1. So that leaves us with a 1. We have s cubed, take out an s squared, so that leaves you with an s. Now, if we're doing it correctly, those parentheses, those groupings should be the same. These are the same, aren't they? So I can write that as 1 minus s. And if that's gone and that's gone, then what's left over? 3 plus s squared. So you just scratch them out and write what's left over. So that's going to be your final answer for that first question. And that's as far as you can go. Question 4. Now, question 4, we want to see if this has been factored or not. And how do we tell if something's been factored? Well, if it's been factored, then nothing else will come out of any of the parentheses. So let's look at our first set. 6 and a 7, do they have a number in common? No. Do they have a variable in common? No. Same thing on the second set. 6 and a 7, do they have any number in common? No. No variable in common either. So this one is, has it been factored? Yes, it's already been factored. So that's what I want for that one, because there's nothing that can come out. If we could factor a number out, then it would be no, and we would have to factor it out. But in this case, it's already been factored. Question 8 is another factor by grouping problem. And what we have on question 8 is we have a t squared plus 9t plus 5t plus 45. We've got our 4 terms, so that tells us that we need to factor by grouping. So the first 2 pieces, what can I factor out of that? Well, can someone tell me what I could factor out of what I've got underlined there? Yep, just the t can come out. And that leaves you then with a t plus 9, right? When we factor the next 2 pieces, we should end up with a t plus 9. So let's look at our numbers. We've got a 5 and we've got a 45. So what number will go into 5 and 45? Well, the only number they have in common is a what? 5. So we're going to take out our 5. And that then leaves us with a t. And what about 45? 45 divided by 5, that leaves you with a 9. We know we're on the right track. Why? Because these groupings are identical. So we'll take out that t plus 9. So that's going to come out, and that's gone and gone. And what's left over that didn't get crossed off? T plus 5. So you cross it off, those parentheses, that comes out in front, and then you simply write down what's left over. And that's as far as we can go. Nine is another factor by grouping. And this applies when you have 4 terms. So we have w plus y, yw plus y, plus w plus 1. So first 2 pieces, what variable do they have in common? They have a what in common? They have a y in common. So that y will come out. And what's left over? W. Now, when you take that variable out and it's completely gone, what do we leave? We leave a 1. So that's W plus 1. The next two pieces, they don't have anything in common. And if they have nothing in common, you can always take out a 1. If nothing comes out, you take a 1 out. And that leaves you then with a W plus 1, right? Now, are my groupings the same now? Yes, if they're not the same, rework it because you made a mistake. So these are the same again. So we'll take out that W plus 1. And what's left over? Well, what's left over is Y plus 1. Once you do several of these, it starts to make more sense. And hopefully this is going to help us with the next section as well, because the next section is more a factor by grouping. Okay, question 14. Question 14 is decide if this has been factored completely. And how do we determine if it's been factored? We look at each group, each set of parentheses. 4 and a 5, do they have anything in common? No. 8 and 1, do they have anything in common? No. So has this been factored? Yes, this has already been factored. You just look at each grouping individually and see if pieces can come out. Okay, next we're going to look at question 15. And for question 15, we have a 6r squared plus 27ry minus 2rx, or xr either way, and a minus 9xy. First thing we do is we see if we can factor a number out of all of this. And there's nothing that can come out because of the 2, right? Because it has to go into all three of them. And 27 does not have a 2 in it. Neither does 9. So nothing will come out. They don't all have the same variable that can be factored out either. So nothing can come out. So we now begin factor by grouping. And the first two pieces, 6 and 27. So what number's in common with both a 6 and a 27? 6 and 27 have a 3 in common, right? Okay, so we'll factor out that 3. And then we look at the variables. These both have an r in common. So we're going to take out a 3r. Now we write what's left over. So 6 divided by 3, that's a 2. R squared, we take an r out, so that leaves you with an r. Then we've got our 27, and 27 divided by 3 makes it a 9. The r comes out, and that leaves you with a 1. Next two pieces, we're very close. See how this looks very similar to this up here. Well, what do we notice about the signs? Let's deal with that first. These are both positive. These are both negative. Remember your rule. If it begins with a negative, you're going to have to factor it a negative. 9 and 2 have no number in common, but they do have the variable x in common. So that negative x can come out. And whenever you factor out a negative, what does that do to your signs? That's like multiplying by a negative, right? And that changes your signs. So that then becomes negative divided by negative makes it a positive 2r. Negative divided by negative makes it a positive 9. The x came out. Y. Are my groupings the same again? Yes, they are. So that could come out as 2r plus 9y. What do we do next? Cross them out and write what's left over. So what's left over? 3r minus x. And that's going to be your final finished answer. So is it kind of making more sense what to do? We do the same process in 5-2, but we have to add an extra step to get to this point, to get to the factor by grouping point. Did we have any other questions out of 5-1 to look at before we move on to 5-2? If not, then we'll go ahead and look at 5-2. And we're going to begin with question number 1. And we've got 42 m squared plus 61 mn plus 14 n squared. We may be able to factor something out. Let's see if a 7 will go into that 61. Nope, and it won't. Okay, so nothing else is going to come out, I don't think, because we've got a 14, which has a 7 and a 2 in it. We've got a 42 that has that 2 in it, but 61 does not have a 2 in it. So nothing is going to come out. How do we handle this one then? We take our first number, because we have our 3 terms. When you have 3 terms, you take the first number times the last number. And that gives you then 42 times your 14, and that's a 588. Okay, so place that 588 in the box. Now what we then do is we figure out our signs. So we look in the middle. That's going to dictate the larger sign. And then we look at that 588. Well, 588 is a positive number, right? Okay, so how do we multiply and get positive? There's only 2 ways that can happen. Either both positive or both negative. Now, what's the sign in the middle that I circled there? Positive. So what are these both going to be? Positives. Now we need to find our numbers. And this is where it's just a trial and error. Okay, so I'll move this so we can see the numbers that I'm going to be dividing here. We need that 588. Now 588 is an even number. So that means we're going to try things like 2, 4, 6, 8, and so on. 588 is a pretty large number, so let's start with a 12. See if 12 will go in there. Okay, and 12 gives you 12 and 49. And 12 plus 49, well, what is that? 12 plus 49 is a 61. That's what we needed in the middle. So what are my 2 numbers going to be? And that was just a trial and error. Now, we could have started with a lower number and had to work our way up. But I was able to kind of look at that and I said, well, 588 is a pretty large number. It's even. So if it's even, we know we need a number that's even also. So we tried that 12. 12 seemed to work. 12 and 49. We write a larger number first, smaller number down below. And how do we check that? Well, 49 times 12, what is that? 49 times 12 is 588, which is the number in the box. 49 plus 12, what is that? 61. And that's the number in the middle. So they multiply together to give you the number in the box. Add or subtract to give you the number in the middle. Then we rewrite it. And we're going to work this one out just like we did a moment ago in 5-1. So we split up the middle. So now we've got 42m squared plus the two numbers 49mn, a 12mn, and a 14n squared. Okay, so we split that middle down. When you have three terms, you make it 4, then you factor by grouping. And the first two pieces, well, we have a 42 and we've got a 49. 49 is a perfect square of 7. So let's see if we can take a 7 out. And 42 is divisible by 7, right? Goes in there 6 times. So we're going to take out a 7. And then what variable? They both have an m in common. So a 7m comes out. All right, so now let's work with what we've got. 42 divided by 7. 42 divided by 7 is a 6. We took out an m from here, so that leaves you with an m left over. We know that 49 divided by 7 is a 7. We factored that m out, so that leaves you with a 7n. Now we repeat the process with the next two pieces. 12 and a 14, what do they have in common? They're both even numbers, so we're going to take out a 2. What else do they have in common? They have an n, so that leaves you then with 12 divided by 2, that leaves you with a 6. The n came out, so that leaves you with a 6m. Now, we know we're on the right track. Why? Because 6m here is the same as that 6m there. So we know we're making progress. If those numbers don't match up, you've got a problem. You've got to go back and rework it again. But they should work. If you did everything correct, they'll match up every time. What about 14? 14 divided by 2. Well, 14 divided by 2, that leaves you with a 7. We took an n out of here, so that leaves you with an m left over. We know that we did it correctly because these are the same. So we write out our parentheses, so 6m plus 7n, gone and gone. And what's left over? 7m plus 2n. And that's as far as we can go. So in 5-2, for the majority of these, we're going to be taking those three terms, breaking them up into 4, and factor by grouping. There's other ways of factoring these. You can guess and check. But I think grouping is the easiest for students to understand. It's very mechanical, and it's the same every single time. I think it's much easier than trying to guess the factors. Question 4. Okay, so question 4, we're going to have to factor something out at the very beginning. So we have a minus 2x cubed minus 8x squared plus 64x. When I see this problem, the first thing I need to look at is my first term. And you notice that that first term is negative. Whenever that first term is negative, I have to at least factor out a negative. I might be able to factor more out. In this case, I can. I'm going to factor out a negative. And what about a 2, 8, and 64? Those are all even numbers, so I'm going to be able to take a 2 out of all of them. 2 divides by 2, 2, 8, and 64. What else do they have in common? They all have an x, so that can come out also. So we factored out our minus 2x. So those cancel. Negative and negative makes it a positive. X cubed, take out an x, that leaves you with an x squared. Negative 8 divided by negative 2, negative and negative makes it a positive 4. X squared, take out an x, that leaves you with an x left over. Then we've got 64. And 64 divided by 2, that leaves you with a 32, doesn't it? And watch your signs. Positive 64 divided by a negative 2. Well, what does that leave you with? Not a positive. It leaves you with a what? Negative. So that's going to leave you with a negative 32. Because when you factor out that negative, it switches your signs. Now, on this one, we can skip the factor by grouping. When it has no number in front, we put a 1 there. And whenever you have to put a 1 in front, you can skip the factor by grouping. If you want to do factor by grouping on all of them, you can, but it's just one extra step. So 1 times a negative 32, well, that leaves you with a negative 32. Now we look at our signs. How can we multiply and get a negative? The only way you can multiply two numbers to make it negative is one positive, one negative. And that's because of that negative there. So that tells me then one is positive, one is negative. Then we look in the middle. And what's the sign in the middle? The middle part has a positive. So that's going to be up top because that's our larger one. Negative is going to be down below. So we need two numbers that multiply together to give you negative 32. And they're different signs, so they're going to subtract to give you that 4. So let's start with 32. 32 is an even number. So we'll start with 2. Now you can begin with 4 or 6 if you'd like. We'll just start with 2 and see if that's going to work. Well, 2 and 16. Does 2 and 16, does that give you 4 when you subtract them? No, that gives you 14, right? We don't want 14, we want 4. That tells me then I need to go up. All right, so when the number is too big, you have to go up. So that 2, let's try a 4. Well, that's 4 and 8. And what do we know about 8 minus 4? Well, 8 minus 4 is a 4, isn't it? So that tells me then that my two numbers are going to be what? They're going to be positive 8 and negative 4. Because 8 times negative 4 is that negative 32. And 8 minus 4 is the 4 that's here in the middle. So that's how we were able to check it. We do not have to do grouping because of the 1. So whenever we had to add that 1 in, we don't have to do grouping. We can actually just jump to our factors. So that x squared, we split that up as x and x. And then what are my two numbers? 8 and negative 4. So we need a positive 8 and a negative 4. And what comes down? It's still there, a minus 2x. So that is your fully factored answer. And we were able to skip factor by grouping because we had to put that 1 there. Whenever you have to put a 1 there, it's an easier problem. You can jump straight to your factors. Let's look now at question 14. Question 14 is similar to question 4. A little bit different, but it's still similar. So for question 14, we have a 2x squared minus 6xy minus 8y squared. And so our first step is to look at the three numbers that we have to see if something can factor out. We have a 2, a 6, and an 8. So 2, 6, and 8 all have a 2 in common. Always do that first. See if there's something in common. So a 2 can come out. Now, can we take a variable out? No, because this one does not have an x. So we cannot take a variable out. We took our 2 out. What's left over? Well, 2 divided by 2 is 1, so that's gone. So that leaves you with an x squared. Negative 6 divided by 2, that's a negative 3xy. Negative 8 divided by negative 2, that's a negative 4y squared. We have to add the 1. The 2 out in front just stays. All it does is just drop down to the next step. So when you factor something out, you don't have to worry about it and just bring it down to the last step. So we factored that 2 out. So that 2 we don't have to worry about anymore. Now we've got 1 times negative 4. And 1 times negative 4 is a negative 4. This is negative, so what do we know about the signs? One number is positive, one number is negative. We look in the middle, and that tells us our largest sign. So the middle is negative, so the larger sign is negative, smaller sign is positive. When we look at 4, what do we have for our factors? 4, we've got only 2 choices. 2 and 2 or 4 and 1. That's it, right? Because that's the only way we can factor 4. 4 is either 2 and 2 or 4 and 1. Well, 2 and 2 doesn't work because 2 and 2, when you subtract them, would give you 0. We don't want 0, but what about 4 and 1? Well, 4 and 1 is going to work because 4 minus 1 is what? 3. See, it matches with that 3 there. So we need then a minus 4 and a positive 1. We can check because minus 4 times 1 is minus 4. That matches. And then we have minus 4 plus 1, and that's a minus 3. That matches. Because of that 1, we can jump directly to our factors. If that would have been a 4 or a 5 or a 2 or anything else here, we would have to factor by grouping. But in this one, we don't. Now, what variable do we have in common at the beginning? X squared. So we can write that as x and x. And then we've got a minus 4 and a positive 1. We don't have to write the 1 because what's our ending variable? Ending variable is y squared. So we can split that up as y and y. And you could put the 1 there, but it's not necessary because we have the y to go with it already. That is your final, factored, finished answer. And once you do a lot of these, you'll get really good at them. And you do a lot of these in college algebra too. So there's a lot of review in college algebra. In college algebra, we review factoring for a class period before we start actually using it. So you'll see it again, but it's nice to have it already down. This way, when you go to college algebra, you can factor, and that's a lot of it. Question 20. Question 20 looks a lot more intimidating than what it really is. It looks really complicated, but it is not. It looks like one of those problems that's going to take you a long time to go through. And it's not. It's one of the easier ones. When I look at this question, it looks intimidating, right? Okay, when I see this question, I think there's going to be a lot of steps involved here. But when I look at it, I look for numbers, variables, or groupings that I can factor out. Well, when I look at this, it looks like they all have an a plus b, and all of them are a plus b quantity squared. So they are all the same. So since these all have the same factors, we can take out that a plus b quantity squared first. So that's factored out. Now we just write down what's left over. So that's gone. So that leaves you with an a squared. That's gone. That leaves you with a minus ab. That's gone. That leaves you with a minus 20 b squared. Now it looks like the others. So now it looks a lot easier to deal with. So we factored out that a plus b squared. So that is gone, right? We don't have to worry about that anymore. It's factored out in front. All it does is drop down. So don't worry about that at all. If you need to, just cover it up just like that. So look at what we've got left. We've got a trinomial left. Trinomial, we have 3 terms, right? So we're going to factor this one like the other trinomial. So that piece out in front, that's gone. You can cover it up if you want to. All that does is drop down. So if we look at what we've got here, well, what do we need to do? So look at that second set of parentheses here. Don't worry about the first one because that's factored out. We can put a 1 here. And then we can take that 1 times that negative 20. And 1 times a negative 20 is a negative 20. That sign is negative, so what does that tell us? One number's positive, one number's negative. And what's the sign in the middle? Negative. So we need a negative up top because it's larger and a positive down below. Okay, I'm going to let you try to figure out the 2 numbers that are going to work. What 2 numbers multiply together to give you 20? Subtract together to give you that 1 in the middle. Multiply together to give you 20. Subtract together to give you 1. Can you tell me the 2 numbers? Yep, negative 5 and positive 1. Or, sorry, 4, not 1. But we need a negative 5 and we need a positive 4, right? Because 5 times 4 is what? 20, okay? Positive and negative makes it that negative 20. And minus 5 plus 4, what is that? Negative 1. That's what we have in the middle. We don't usually write it, but if you need to, you can put the 1 there. If it helps make more sense, you can do that, right? Because there's no number there, so we can put the 1. So let's go ahead and see if it works. We talked about it. Let's check it real quick. Negative 5 times 4. Negative 20. That matches. Minus 5 plus 4. That's negative 1. That matches. Almost done. We don't have to do grouping because of this 1. If it was any other number, we would have an extra step. This one does not. So what do we know? What's our beginning variable? A squared, so we split that up into a and a. What are our numbers? Minus 5 and positive 4. What's our ending variable? Ending variable is that b squared, so we split that up into a b and a b. And do not forget to bring down your a plus b quantity squared. That is your final finished answer. A lot of times the hardest part is trying to find the two numbers. Once you found the two numbers, then it's really not that difficult. That's where the problem lies, is trying to find these. 24 is next. (24) is u squared minus 2uv minus 80v squared. Well, nothing can factor out. No variables in common, no numbers in common. That means we're going to put our 1 out in front. 1 times that negative 20. What is 1 times a negative 20? Negative 80. Since it's a negative, what do we know? One number's positive, one number's negative. What's the sign in the middle? Negative. So what do we know? Negative goes first because it's larger. Positive is second. How would we factor this out? Does anyone know what the two numbers would be? Anyone want to take a guess? Two numbers multiply together to give you 80, subtract together to give you 2. Yep, 8 and 10, right? Now, why would I start with 10? Well, I would start with 10 because what does that 80 end in? A 0. If it ends in a 0, it has to either have a 10 or a 5 in it. So you would start with things like 5, 10, 15, and so on. Now, it ended in a 0, and I wanted that difference to be 2, so I could look at it, and I could say, well, let's start with a 10. So I could use a minus 10 and a positive 8. So if it ends in a 0, you have to have either a 5 or a 10 in some combination. So 5, 10, 15, 20, 25, and so on. It has to have one of those in there. We tried a 10, and 10 happened to work. Because negative 10 times positive 8, what is that? Negative 80. Negative 10 plus 8, what is that? Negative 2, which matches the middle. Okay, that's what we wanted. We use that 1 so we don't have to do grouping. Our beginning variable is a u squared, so we split that up into u and u. What are my two numbers? -10, +8. What's my ending variable? If I have one, in this case I have one, and it's v squared, so I can split that up into v and v. And that's as far as I can go. Factoring is basically a puzzle, figuring out how the numbers work together. That's all factoring is, just a puzzle. Rewriting it in a different way. One more, then we'll take a short break, and we'll come back, and we'll look at question 10. So question 25 is going to be our last one before we take a break. And let's look now at question 25. This one is going to make us do factor by grouping again. When I see a question like this one, the first thing I look at is I look at all the numbers. 49, 14, and 15. Nothing's in common. But what do we have out in front? We have a negative. Whenever there's a negative out in front, you need to factor it out. No number in common, no variable, but there is a negative. So that whenever there's a negative, whenever it starts with a negative, that negative needs to be factored out. It just makes it easier. So that switches our signs. That makes it a positive 49x squared, a positive 14x, and a negative 15. First times the last. And the numbers here might be kind of large, but we can work with them because we do have a calculator. So let's take our 49 times that negative 15, and that's going to make that a negative 735. And this is probably the most complicated one to factor because the number is pretty large. So this is negative. So what do you know? One number is positive, one number is negative. What's the sign in the middle now? After we factored out that negative, it switched and it became a positive. So the larger number is positive, smaller number is negative. Now, where do we begin? Well, when I look at that 735, right, I look at it and I see there's a 5 in it. It ends in a 5. So what does that tell me? That tells me I need to start with factors of 5. It has to have a factor of 5 in it. So we're just going to work through the factors of 5 until we find it. So it's trial and error from here. So what's our number? 735. And we're going to divide that by 5. That's 7 and 147. Nowhere close to 14 when we subtract them. Now, it doesn't end in a 0, so we can't use a 10. So let's try a 15. 735, we'll divide that by our 15. 15 and 49. Do those subtract together to give us 14? No, but we're getting closer. 20 is not going to go in there because it ends in a 5, not a 0. So let's try 25. 25 doesn't go in there. 30 is not going to go in there, but how about 35? 35 and 21. I think that's going to work because 35 minus 21, what is that? 14. See how I worked it out though? Look at what it ends in. if it ends in an even number, it has to have an even number as one of the factors. That's just the way it has to work. If it ends in a 0, it has to have either a 5 or a 10 as one of the multiples. If it ends in a 5, it has to have factors of 5. So 5, 15, 25, 35, and so on. So when you look at the numbers, look and see what it has at the end. If it's an odd number, like a 7 or it ends in a 3, those are more difficult, and you're going to have to try different odd numbers, like 3, 7, maybe 11, things like that. But look for patterns with these numbers. So it ended in a 5, and so we tried 5, we tried 15, we tried 25. We eventually got it because we used a 35. Now, how do we check? 35 times a negative 14, well, that's a negative 735. And 35 minus 14, oh wait, not 14, 21. My mistake. I wrote down the wrong number. I was looking at the middle. That should be a minus 21. Sorry about that. I wrote down the wrong number. I was thinking of the answer. So that should be a 21. Sorry about that. Okay, and 35 minus that 21, what does that give you? Okay, 35 minus 21, that gives you your 14, right? Okay, so our two numbers are 35 and 21. Multiplying them gives you a minus 735. Subtracting them gives you that 14. Now we cannot just jump to our factors. If this was a 1, we could go directly to our answers, but it is not. So what do we then have to do? Split the middle to do factor by grouping. So when I split up the middle, I've got 49x squared. I'm going to split that 14 up now into a 35x, a minus 21x, because those are my two numbers here, and a minus 15. Don't worry about that negative, because that's just going to drop down. It's out in front, so we don't even have to worry about it. It's basically gone, right? So don't worry about it, because it's going to drop down. Now we've got our 4 terms, so what do we have to do? Factor by grouping. 49 and 35. Well, 49 is a perfect square of 7. So our only choices are 7 and 7 or 49 and 1. Well, 7 also goes into that 35, doesn't it? So I know I need to factor out a 7. They also have the variable x in common. So I'm going to factor out a 7x. And if I factor out a 7x, what does that leave me with? 49 divided by 7 is a 7. X squared, take out an x, that leaves you with a 7x. 35 divided by 7, okay, 35 divided by 7 is a 5. And the x is gone, came out. Now we repeat the process for the next two. If it begins with a negative, we're going to have to factor out at least a negative. We're going to probably factor out more here, but we're going to factor out a negative to begin with. 21 and 15, what do they have in common? 21 and 15 have a 3 in common, don't they? Right, you've got to find the number. Now, if you struggle trying to find the number, look and see what you need. I need a 7x. What's 21 divided by 7? 21 divided by 7 is a what? 3. So that gives you a little bit of an easier hint to get the number. You need a 3. So we're going to factor out a negative because it began with a negative, and these have a 3 in common. Negative 21 divided by negative 3. Negative and negative makes it a positive x. See how these match. We know we're on the right track. Negative 15 divided by negative 3. Negative and negative makes it a positive 5. Did we do it correctly? Yes, these match. These are the same. So that's going to come out as a 7x plus 5. Gone and gone. What's left over? 7x minus 3. Do not forget, what else do we have to bring down? So always go back and make sure you didn't factor something out. Now, we did factor out the negative. All that does is come down. And that is your fully factored, finished answer. And that is as far as you can possibly go. We're going to take a short break. We're going to come back, and then I'm going to work out question 10 for you, just so you see how one of those works. And then we're going to work on our practice final. We'll work out some of those questions in class. Whatever we don't work out is already worked out for you. So you can see how I did each one of the practice final questions step by step. So let's take a short break, and let's meet back here at 9:45. So we'll meet back here at 9:45, and then we're going to look at our practice final and also question 10.